So yesterday we reviewed some basic limit problems. So recall. So the one thing we learned is that the limit tells us what the value of a function is approaching. Remember, this is not the value, and we solved it in how we write it. The limit would be written as a limit as x approaches some number of a function. This is giving us what we are approaching. The value of a function we would write as f of x, and this tells us what the function is, what we are at. So a way we described a limit is to say, well, what if we could substitute it? And we talked about this when we got those indeterminate type of functions, where if we plug in, we would get 0 over 0, or we would get infinity over infinity. So that's what the limit tells us. If we could plug in a number, what would we get? Today, what we're going to look at is some special trig functions. So now, another thing we said yesterday, and this was very big for us, is if the limit of the function equals a value, we said that that function was considered continuous at that point. For example, if we let f of x equal sine of x, we get x equals 0. If so, we would get like sine of 0 would become 0. The limit, well, if we did the same thing, this says x approaches 0 of sine of x, well, that's also going to become sine of 0, which is 0. These are the same. So because the value and the limit are the same, we would say that this function is considered continuous at x equals 0. However, recall last year, not every function has an infinite domain. Let's look at the function sine of x over x. What happens if we plug in x equals 0 here? So we would say the sine of 0 over 0, we would get 0 over 0. Notice this is our indeterminate. We don't know what that is. So this does not have a value. So we can't know what it is, but we could do is find out, well, what if we could plug in 0? What would the function then be approaching? And that's what we're going to talk about. Look. So here we have the graph of sine of x over x below. What can we say about the value? What can we say, that the value approaches as x approaches 0? Well, here's x equals 0, and I'm going to write that in pen here. Here x is 0, and as we approach from the left and the right side, it looks like we're approaching 1. So we could say as x approaches 0, the function f of x approaches 1. But of course, we would write that as a limit. So in mathematics, we would say this, that the limit as x approaches 0 of sine of x over x is 1. In other words, we approach 1. Now, how we prove this is something called the squeeze theorem. And in a supplementary video, I will show how we actually can prove this mathematically as well as conceptually. And it's pretty cool to do. Okay, all right. So, but today, though, in this video, let's just really kind of focus on these special trig ones that we're going to be seeing all throughout the year. And we have some special rules. We have 3 rules for us. The first rule says the limit as x approaches 0 of sine of x over x is 1. That's our first rule for today. The next one, tangent of x over x is also going to be 1. Now, likewise, if you were to flip these, what if I did the limit as x approaches 0 of x over sine of x? Well, that's right here. It's just like saying 1 over 1. So, of course, this would also be 1 as well. The same thing for tangent of x over x. The limit as x approaches 0 is also going to be 1. Now, the next one, and again, we're not going to prove this. We could prove it with what we call a squeeze theorem. but we're just going to take Mr. Warnell's word on this one. The limit as x approaches 0 of 1 minus cosine of x over x is 0. Now here's a tricky one. Here's a fun one for you. What would happen if we flipped this one? What would we get? If you guessed D and E, you're absolutely right. And let's take a look at y. Remember how we thought this could be like 1 over 1? Well, if I flip 1 over 1, I just get 1. This is saying 0 over 1. If we flip 0 over 1, we get 1 over 0, and therefore it does not exist. We don't really see this one too much. So let's take a look at some examples here. So we have the limit as x approaches 0 of 5x over 4x. Now, the important things to remember is that these just have to be the same, must equal each other. In other words, we have to make this a 5x and we have to make this 4x a 5x. So I just got to think about what can I multiply it by. And that's, for the most part, pretty easy done. If I want to make 4x into a 5, I just have to multiply it by 5 over 4. I multiply the bottom by 5 over 4, and I multiply the top by 5 over 4. And rewrite out your limit as x approaches 0. This becomes sine 5x. Now, if I multiply these two together, I'm going to get 5x. So that one's done. But notice I'm left with this 5 over 4, so I just put that off to the side here. Now, our rule, this is our rule for today. This is just 1. So we're left with 1 times 5 over 4. And that just becomes 5/4. For an example like number 2, be careful. It kind of thinks like it's cosine, but we're using sine of x. So we want sine of x over x because we know that that becomes 1. So I can split it here. So I'm going to rewrite this as a split. Sine of x at limit as x approaches 0, 2x over x plus sine x over x. Using a little bit of algebra, be very careful. A lot of times people don't plug in 0. If you plug in 0 here, you're going to get 0 over 0. And we don't want that, okay? Don't plug in 0 here. We get 0 over 0. We don't want that. That's bad. But I can cancel those x's, and that's exactly what I'm going to do. Cancel them. I get 2 plus sine of x over x equals, this just stays 2. And we said sine of x over x is 1, so that becomes 2 plus 1, which is 3. Very easy to do. A lot of fun. These are a lot of fun. All right, number 3 is probably the hardest one we will ever get here. And so let's see here. Now notice here I have 2 sine 3x and sine of 2x. That's a lot. So, but because it's dealing with sine, I want sine of x over x or x over sine of x. As long as these are the same, I'm okay. And I almost have that. As long as the x is the same, I almost have that. I almost have it. For example, I have this 2 and this sine of 2x. All the 2 needs is an x. So I am going to rewrite this with what I like, 2 over sine 2x. But I'm still left with the sine of 3x. And I'm going to put this over 1. And I think what I need, this right here needs an x. The bottom here needs a 3x. So I just have to get kind of creative. It's kind of fun. So if I look at the first one, this 2 over sine of 2x right here, what can I do to the top to make that a 2x? And you're right, I'm going to multiply the top by x. But if I multiply the top by x, I have to multiply the bottom by x. It's like an extra with this. Now I'm going to deal with the sine of 3x part. Well, the bottom, it needs a 3x. So I'm going to multiply the bottom there by 3x, like that. So I get 3x down here, and I have to do the same for the top. Don't cancel anything out. We're just going to organize everything together, and then we'll take care of the arithmetic. So this x belongs to that 2. So I can now rewrite this. The limit as x goes to 0, 2x over sine 2x. This 3x goes to that 1 because I want that 1 to be at 3x. So we get sine of 3x over 3x times, and now I just find out what's left. What's left over? I got the 3x and the x's just cancel. Make sure you cancel them out. And the rest is pretty easy. Well, 2x over sine of 2x, my rule says that's 1. 3x sine 3x over 3x, again, that's just going to become 1. That's my rule. So I'm left with 1 times 1, and I have, don't forget that additional 3 right there. So I'm left with 3. That just becomes 3. So this is approaching 3. Very easy to do. A lot of fun. All right, for number 4 here, again, no cosine. We're looking for sine of x over x. So I think, is there any way I can get sine of x over x? And here we have the limit as x goes to 0, sine of x over x squared plus 2x. And to do this one, well, I can factor out an x on bottom. Sine of x over x times x plus 2. And if I rewrite that, the limit as x approaches 0, I can write this as sine of x over x times 1 over x plus 2. And again, this I already know is 1. For here, for the second one, if I plug in 0 for x, we would get 1 over 0 plus 2 and a final answer of 1/2. So that's just approaching 1/2. In another video, I'm going to do some of the homework questions with you, so make sure you check that one out, okay? All right, well, I hope you enjoyed this video. In the next video, we're going to take a look at what we call the squeeze theorem. And it's a really cool little video, so I hope you guys enjoy it. See you soon. Bye-bye.